Everybody. My name is Sodiomon. You think that chemistry exists only in labs, right? But there is a bigger chemistry lab outside, in the real world. Hard to believe? No worries. I am going to show the biggest chemistry lab, our world. Hey Tina. What's up? Enjoying at the airport? I see. You are dancing at the airport? Quite weird.
Hey Sodi. You silly. I am not dancing. I am just happy. I am traveling to New York, then to Chicago, then to Paris, then to London, then to Munich, then to India, then to Bangladesh, then back to Deloitte. Isn't that cool?
Haha. Yeah, cool enough. But you do know that the reason behind you traveling to so many places is chemistry.
What chemistry? No, it's because I have bought the ticket to so many places.
It's all chemistry. First of all, the airplanes, in which you fly are made of aluminum. And aluminum is a transitional metal. They are the central block of the periodic table. The reason they are used to make vehicles like cars and aeroplanes are because they are light in weight and they are less reactive. Thus, if the engine gets too hot, no worries. Transition metals have high melting points. It'll not burn off. As well as, they are much stronger. So, 80% of the elements are metals. In addition, for your knowledge, aluminum symbol is Al and its atomic number is 13. So, what's the use of your tickets?
Oh my god. That's a lot of chemistry. Okay, getting late for my flight. See you later at the lab, bye. Thanks for enlightening me.
Have a safe flight in the air, made of two main elements, oxygen and nitrogen. The other elements include argon, 1%, krypton, hydrogen, xenon, ozone, ammonia, and iodine. The formula of oxygen is O2 and nitrogen is N2. And oxygen and nitrogen are anions, which means that they are negative ions.
Thanks for your chemistry lesson. Bye.
The petrol we put in our cars. The bottles that hold our milk. And the lubricants on bike chains all originate from one liquid. Crude oil, found deep in the Earth's crust and brought to the surface by oil rigs. How do we get all these useful products from this thick brown liquid? The answer lies in an ingenious process called fractional distillation.
Okay. Class. Let's start off with our class on fractional distillation. Yes sir, let's ignite our brains. Sure sir. So, first of all, what is fractional distillation? What is it characterized as? Where all is it used in the industry? Well, I think that fractional distillation is a method used to make tea. You know, like the boiling and all. Just optimistic, I mean it's just used at homes to make tea and coffee. That's my guess.
Sir, I think it's used as a separation technique. That's all I know.
Well, Simon, you were close enough. But David, I am not very happy with you. You aren't concentrating enough. Anyways, fractional distillation differs from distillation only in that it separates a mixture into a number of different parts, called fractions. A tall column is fitted above the mixture, with several condensers coming off at different heights. The column is hot at the bottom and cool at the top. Substances with high boiling points condense at the bottom and substances with low boiling points condense at the top. Like distillation, fractional distillation works because the different substances in the mixture have different boiling points.
Sir, then how can we separate crude oil using fractional distillation?
Because they have different boiling points, the substances in crude oil can be separated using fractional distillation. The crude oil is evaporated and its vapors are allowed to condense at different temperatures in the fractionating column. Each fraction contains hydrocarbon molecules with a similar number of carbon atoms. What all substances can be made out of crude oil? How are they separated? The substances made out of crude oil include petrol, diesel, natural gas, bitumen, etc. The substances are separated according to their boiling point. For example, petrol and other fuels have low boiling points, so therefore they boil faster, ignite easily and condense before the others. Whereas, bitumen is produced the last as it is the residue of all of them. It is used in the production of roads, cement, etc.
Sir, what other separation methods are used in the industry?
Other separation methods include filtration, distillation, chromatography, crystallization, and evaporation.
Sir, what's happening there at the crime scene?
I am scared. Oh, that's chromatography, another separation technique. As you can see, the ink mark and blood stains on the paper will get separated into different colors, from which it's made from. This way the substance can be easily identified. As well as, the further up the substance goes, the more soluble it is in the solvent. Using these evidences, they can try to investigate the victim. Cool. Brilliant. That was cool.
Actually cool. Chemistry is cool. It's everywhere.
It's like adventure.
Look at the tire. It has got punctured.
Nope. It's not punctured. It has got deflated. What do you think, Sodiomon, sir? Yes, it's deflated. Again, chemistry is observed here. When you will fill it up with air, it'll get inflated. Air is a gas, which means that the atoms of air are away from each other. Unlike solids, they don't have a lattice, which means they don't have a definite position. Also, their force of attraction is really low, therefore, they bounce against each other and move apart. This doesn't happen in solids and liquids. So, when you squeeze air into the tire, the rate of collisions increases as the tire is a smaller place. The gas particles now don't have much space in the tire, and thus bounce against each other more often and push against the tire, causing it to inflate. Isn't it interesting? So, we owe it all to chemistry. Sir, you and your chemistry. Blah. Now, we must find an air pump.
Sir, before we start our journey on foot, I have a question.
How do those ad screens run? It seems futuristic to me. I have never seen one before today. Oh, that's LCD technology. The basis of LCD technology is the liquid crystal, a substance made of complicated molecules. Like water, liquid crystals are solid at low temperatures. Also like water, they melt as you heat them. But when ice melts, it changes into a clear, easily flowing liquid. Liquid crystals, however, change into a cloudy liquid very different from liquids like water, alcohol, or cooking oil. At slightly higher temperatures, the cloudiness disappears, and they look much like any other liquid. When the liquid crystal is a solid, its molecules are lined up parallel to one another. In the intermediate cloudy phase, liquid, the molecules still retain this more or less parallel orientation. As in any liquid, the molecules are free to move around, but they tend to line up in one direction, reflecting light and causing a cloudy appearance. Higher temperatures tend to agitate the molecules and thus make the liquid clear. This is where the future of chemistry lies, liquid crystal chemistry. I, myself, am doing research on that. Ah, cool. Interesting. Boy, can you please remove those glasses? Yes, sir. So, let's start our journey towards home. We can squeeze the gas tomorrow,